All right, future chemists, welcome. Today, we're going to crack the code on one of the most important topics for your SPM exam, chemical bonds. If you stick with me, I promise that by the end of this, you'll be tackling these questions like an absolute pro. But hang on, before we jump in, we need to talk about the real key to success, and that's practice. I mean, theory is great, but applying it is what's actually going to get you that A. So go ahead, scan this QR code, or just head over to mcqpm.com. It's also on the Google Play Store. Seriously, this is your secret weapon. It is jam-packed with past year questions that will turn everything we're about to learn into real exam day confidence.
So, here's our game plan for today. We'll start with the golden rule of why atoms bond in the first place. Then we'll decode the two big ones, ionic and covalent bonds. After that, and this is super important, we'll look at the common exam traps that catch so many students out. We'll finish up by mastering metallic bonds, and then I'll point you to the best place to practice. Sound good? Let's do this.
Okay, first things first. Why do atoms even bother to form bonds? I mean, what's the point? Well, it all boils down to one simple, fundamental drive that pretty much rules the entire world of chemistry, the search for stability. I want you to think of the noble gases, over on the far right of the periodic table. Think of them as the cool kids. They're perfectly happy, perfectly stable, and they don't need to interact with anyone because their outer electron shell is completely full. Well, pretty much every other atom wants to be just like them. So to get that cool kid status, they have to either give away, take, or share their outermost electrons. And that whole interaction, bam, that's a chemical bond. All right, now we're getting into the real heart of it. These are the two main types of chemical bonds that will 100% show up on your exam. And the secret to acing these questions, it's all about learning to spot them in a split second. Okay, if you remember one thing today, let it be this. Ionic bonds are a transaction. It's a complete transfer of electrons. You'll almost always see a metal giving an electron to a nonmetal. Covalent bonds, on the other hand, are a partnership. It's all about sharing electrons, usually between two nonmetals. If you can get that difference, transfer versus sharing, you've basically unlocked how to solve most of these bonding questions.
Okay, time to see this in action. Here is a classic SPM question. The second you read that phrase, transferring electrons, an alarm bell should go off in your head. Ding, ding, ding. That's the code word for an ionic bond. And what's the recipe for an ionic bond? You know this. It's a metal and a nonmetal.
And this animation shows it perfectly. Look at that. Lithium, our metal, just hands over an electron to oxygen, our nonmetal, and what do you get? Lithium oxide, a perfect textbook example of an ionic compound. It really is that simple once you know what to look for. Ready for round two? Let's do it. This time, we're hunting for a covalent bond. So just remember the rule. Covalent means sharing. And who shares electrons? Two nonmetals. Go on, scan the options, and see if you can find the right match. And we have a winner. It's ammonia. Why? Well, just look at what it's made of. Nitrogen and hydrogen. They're both nonmetals, so they're not going to be giving and taking electrons. No way. Instead, they team up, they form a partnership, and they share electrons to get stable. That sharing, that is what a covalent bond is all about. Okay, I need you to pay really close attention now because this section is a potential grade saver. Examiners are clever, They love to set little traps to see who's really been studying. We're about to break down a super common mistake that students make with a molecule you see absolutely everywhere. So here's the question. And what do you see? That big, bold, all caps, not correct. That is a classic exam trick. They're not asking you what's true. They're asking you to find the lie. This question is a test of how well you really understand the structure of CO2. And there it is. That's the trap. On the surface, it kind of sounds plausible, but it's totally wrong. Just think about it. A carbon atom has 4 electrons to share, and an oxygen atom needs 2. So if carbon only teams up with 1 oxygen, well, then nobody's stable. It's like a puzzle with pieces missing. I see students fall for this one year after year. So here's the real story. For every atom to be stable and happy, the carbon atom has to bond with 2 oxygen atoms. And it does this by forming 2 double covalent bonds, sharing 2 electrons with each oxygen. My number one tip for you here is to always try to draw or at least picture the molecule in your head. It will save you from falling into these traps, I guarantee it. All right, let's move on to our final bond type. Now, this one is a bit special. It's what explains why metals are, well, why they're metals.
why they can conduct electricity and heat so incredibly well. We're talking about metallic bonds. Now, the textbook definition can sound a little intimidating, right? You see words like electrostatic attraction, delocalized electrons. It's a mouthful. But please, trust me on this. The actual idea is way simpler and much cooler than it sounds. Let me show you. Just take a look at this. This picture is the key to everything. Imagine you've got this fixed grid of positively charged metal ions, all locked in place. Now, picture their outermost electrons just letting go. They're not tied to any single atom anymore. Instead, they form this amazing, free-flowing sea of electrons that just moves all around the structure. And that free movement, that's the superhighway that lets electricity zip right through a piece of metal. So we've broken down ionic bonds, covalent bonds, and metallic bonds. We've even looked at how to dodge those annoying exam traps. But look, let me be totally honest with you. The only way to truly master this stuff and lock in that A is through consistent, focused practice. So here's my challenge to you. I want you to take everything we've just talked about and put it into action. Go to MCQ SPM right now. Seriously, right after this. Find the chemical bond section and just start doing questions. Test yourself. See if you can spot the bond types. See if you can avoid the traps. This type of active learning is exactly what separates the students who get A's from everyone else. So now you have a really solid grip on what holds molecules together. But as you're practicing, I want a new question to start bubbling up in your mind. We've seen that both water and carbon dioxide have covalent bonds. So why is a water molecule bent while a carbon dioxide molecule is a perfectly straight line? What force is deciding the actual 3D shape of a molecule? That is a fantastic puzzle, and it's exactly what we'll be solving in our next explainer. Until then, happy studying.